One essential aspect of computer programming is for a programmer to be able to store information on a computer, give it a name, and then reuse it over again. This is the concept of a variable. I'm going to show you how to create a variable by taking the result of an expression and assigning it to a variable with a name that we provide. After the variable has been created, whenever we use the name of the variable, it's as if we're substituting in the value that's been stored in the variable. Let me go ahead and demonstrate what this is all about. Let's initially have a look at a mathematical expression that we've previously calculated. How about 3 plus 2? When I press return, MATLAB will print for us to the command window the answer of 5. More specifically, what has happened is MATLAB created something for us called a variable. That variable has the name of ANS and has a value of 5. Now in a subsequent command, I can reuse this variable for a new expression. So I can type in ANS here multiplied by 2. What's going to happen is whenever I use this variable name of ANS, MATLAB will substitute in the value for this expression and complete this whole calculation. So now I've got an answer of 10. Therefore, ANS, when I was using it here, had a value of 5. So MATLAB has implicitly created something for us called a variable that will allow us to store information in our computer's memory and use it over again. Let's have a look then how we can explicitly create or declare a variable of whatever name that we like. So instead of using answer, I'm going to type in here x, then use the equal sign, 3 plus 2. Before I execute this, I did want to say one thing. This symbol, at least in mathematics that's called the equal sign, actually has a slightly different meaning in computer programming. The better way to think about this symbol is as the assignment statement. So in math, when we use an equal sign, the idea here is to compare maybe what's on the left side of an equation to what's on the right side of the equation. In computer programming, we're doing something different. It's always going to be the case that MATLAB will execute the expression that's on the right side of this statement or the right side of the symbol. It will execute that, come up with the result, and assign the result to the variable that's on the left side. So in this case, I'll press return. And the best way to think about this is the value of 5 has been assigned to a variable with the name of x. Now in subsequent commands, I can reuse this variable. I could say x times 3, get answer of 15. I could also do x minus 8. So in this case, it's going to be 5 minus 8, and I get a value of minus 3. I can also use this variable to create other variables. So as another example, I could do y gets assigned the result of the expression x divided by 2. So here, y now has a value. It was assigned the value of 2.5. And I can use y for other things. I could do y times x. So 2.5 multiplied by 5, right? So it might not be obvious so far why this is so helpful, but maybe as a very simple example, let's say we had some other variable we'll call z. Say z is going to be given the value of 5 million. So that's 500, 500,000, and one more. We've got 5 million. So I'll press return. Now, let's say I wanted to reuse this value over and over and over in my program. Well, I don't want to type 5 million every single time, so I could just substitute in z and do all sorts of things. Z times 2, z divided by 4, and you can see this is going to save me a lot of typing. This is a very simple benefit of using variables. You don't have to type this thing out over and over and over again. Let me say a few more things about variables. I'm going to clear off now my command window. All right, up to this point, I've said that our computer is going to store the value of these variables in memory. Even though I've cleared off my command window, the variables that we have created are actually still being stored in memory. So I can use x, see that x still has a value of 5, and y. In fact, if I want to check what variables are still stored in my computer's memory, I can look over here in the MATLAB environment at something called the Workspace. This is going to be where I can see the variables with their names and the values that are currently stored in memory. If I ever want to clear out the variables that are stored in memory, I can type clear. You'll see that all the information in the Workspace has now disappeared. Let me clear off my command window again and start from scratch. There are a few more things that I want to say about variables. So for instance, let's assign a new variable called h. Let's give it the value of 1. We've got h being given the value of 1. One statement that we use a lot in programming looks like this, where we say h gets assigned h plus 1. Again, you have to get used to the fact that this symbol means something very different in programming. If we're thinking in terms of this being a mathematical symbol like equals, this statement doesn't make sense at all mathematically. You can't have a number, h, that's equal to that same number plus 1. But this statement is used a lot in programming where what we want to do is just iterate or count off of a variable. So here we've got h plus 1. We're going to assign it to h again. So what has happened? H has been updated. The value of h has been changed to a value of 2. And we can confirm that over here in our Workspace as well. I can recall that same last statement. What happens now? The current value of h is 2. So we do 2 plus 1. That's 3. And we assign it to h again. So now every time we plug in h, we're going to keep counting. So this is another example how programming works slightly different than mathematics. I'm going to go ahead and clear off my command window again. Show you another thing about creating variables and how you would type them in over here on the command window. One thing we can do is suppress the output of a command that we execute. So as an example here, I'm going to type in r gets assigned the value of 3, and at the end of this statement, I'm going to put in a semicolon. This is one place in our programming language where the semicolon has a specific meaning. The idea here is to suppress the output at the command window. When I execute this command, you'll see that we no longer have the result of it being printed to the command window. So if I remove that semicolon, type in something else, q equals 4, if I remove the semicolon, it's going to print it out there again. There's many times when we're programming where it's just unnecessary for us to print these things to the command window. We've got the statement that we've used right here. We don't necessarily have to have it repeated. So let's create another variable, b gets assigned 7, and then use the semicolon to suppress the output. Even though we don't see the output being printed, in fact, this variable has been added to memory. We can look over here in our Workspace and see that we do have the variables b, h, q, and r. So even though we've suppressed the output, let's go ahead and use some of these variables. So we could do b plus r and see that we've got 7 plus 3 will give us an answer of 10. So hopefully that shows you another helpful thing, and we will be using this over and over and over again when we're programming. It'll be more often than not, actually, that we'll want to suppress the output. So that's all for this video. I've showed you a number of things that will come in handy in the future when we're working with variables.